In this video, we're going to learn how to subtract two vectors. I'm going to draw two vectors on the screen right now. We're going to give them a name, each. The first vector is going to look like this. We're going to call that vector A. I'm going to move this vector to a location that gives us lots of room to work. You'll remember that as long as we don't change the magnitude or direction, we can move vectors anywhere we like. Our next vector is going to be called vector B, and it's going to look something like this. Our goal is to calculate vector A minus vector B. This will be some vector as well, but one thing that we can note to make our lives easier is that this is exactly the same thing as vector A plus the negation of vector B. Check out our video on vector negation if you'd like to learn more about that topic. Since we know that we want to subtract vector B from vector A, and we know that we can do that by adding the opposite of vector B to vector A, let's first find the opposite of vector B. I'm going to slide vector B over a few units, and we notice that vector B has components of 2 to the right and 1 down. If we want the opposite of vector B, we'll want to have components of 2 to the left and 1 up. It'll look like this. We're going to call that minus B. Now we just have a problem of vector addition. I'm going to move vector B out of the way for just a second. And since we now want to add vector A to vector minus B, we know that we can connect the tail of vector minus B to the tip of vector A to add them. And it looks like this. And that vector we know is vector A plus the opposite or the negation of vector B. But look what this tells us. If we move minus B out of the way and replace it with our original vector B, this tells us that if we have vectors A and B tail to tail, the difference between them, that is to say vector A minus vector B, is the vector that connects the tip of B towards the tip of A. Of course, we want to see this in unit vector notation as well. So let's zoom out a little bit, and we'll see what this looks like in unit vector notation. If we look at our vector A, we see that it has components of 3 I hat and 2 j hat. That is to say 3 units to the right and 2 units up. Vector B, it looks like it's got 2 units to the right and 1 unit down. Of course, we want vector A minus vector B, and we know that that is equal to vector A plus the opposite, the negation of vector B. Let's do this by collecting the horizontal components together with an I hat, and we're then going to collect the vertical components together with a j hat. So what we can see is that our final vector a minus b in component form is going to look like 1 unit in the horizontal direction plus 3 units in the vertical direction. So then we ask ourselves, what is the vector a minus b trying to tell us? It says the difference between a and b is a vector which points 1 unit to the right and 3 units up. And if we look back at our graph, the purple vector, a plus minus b, is exactly that. It's 1 unit to the right and 3 units up. Exactly the vector in component form, a minus b.